Okay, I'm going to formally start. Welcome, everybody. I've got about 45 slides. I'm planning on using about 1 minute each and being done with the talk in about 45 minutes, open for questions and discussion. Failing you getting time to ask your question, feel free to use my email, tom@gilb.com, and ask away questions. I'm retired, got plenty of time, love to answer questions from people who are interested in these methods. Get your own personal answer. There's a link to all the slides, which are quite detailed. So if you're really interested, you will want a copy, and the QR code and the DOI codes all do the same thing, essentially. Here is what I'm planning to handle. 9 subjects. Don't worry about it, but you'll notice it's quite a broad set of ideas. Here's my good friend Elon Musk. He's done 2 wonderful things for me. Number 1, earned me a lot of money investing in Tesla shares, which just went up by a horrendous amount today. Thank you very much. And he also is fanatic about building his cars to be incredibly safe, at least for the people inside the cars. And the proof of the pudding is that he's rated independently the model I have, the Model 3, as safest car on the planet. And I can assure you nobody has died in my car yet. And by the way, the point here being that half of the whole car, of course, is an AI system that he's working on to let it drive itself. So I have some questions I'd sort of like you to ask yourselves and your colleagues. My talk is really going to be about AI engineering as opposed to AI prompting and talking and words and stuff like that. And if we take a couple of AI qualities like transparency and security, I wonder how many people here could define those 2 words quantitatively with numbers so we can measure how transparent and how secure an AI system is. Okay, and I'm betting nobody out there will even report to me in the chat or by email that they're doing it or can do it, but I will teach you how during this lecture. You can send your attempts to me and I'll comment on them. But in simple terms, that's what this talk is about. Viewing the AI systems through the lenses of a set of qualities, of critical qualities of the AI system, and doing it in an engineering way, meaning those qualities are not poetic political ideas, they are quantified engineering terms. So I believe that the qualities of an AI system give us some insights into the AI methods themselves. Right now, we have some bad habits where we view things, we say, okay, we're using big data, and we've got a large language model, and we're using data reflectivity or something like that. And it does poems and art. We babble on with words. Oh, it's a very secure, highly transparent system, and we can, it's got great traceability for the conclusions back to references. Blah, 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 right? Easy to use, fairly secure, and it's free for the moment, unless you take the $20 a month option of advanced operators. So, in other words, we refer to and describe our AI systems with words, all of which, if you noticed, are extremely ambiguous with 1 million different interpretations each. In other words, we don't really know anything. We don't really have any shared knowledge about it at all. There are other problems with the systems. For example, the design of the systems is largely secret. Forget open AI. And even the people who built the system tell you they don't really understand what it does and how it does it. And the just again, same problem. A lot of ambiguous ideas floating around. Nobody's pinning it down. I have to admit that there is some good benchmarking regarding AI systems going on in real time that is trying to measure the performance and other aspects of the AI system. So that's good. Okay. Even if you knew something at any one moment in time, the problem is, let's say you knew absolutely for sure exactly what this AI system did. The problem is that the system is so unstable that a picosecond later, by even rephrasing your question with a different word in the prompt and accessing a totally different set of training data, all bets are off, and it could do stupid things, have illusions, lie to you, and all kinds of other things. And the changes are made by unidentified people. In other words, they have no responsibility for unidentified reasons, probably to earn money rather than serve you with good ideas. And since the whole thing's built on software, we're all very aware of the fact that we can get unintended side effects in the algorithms, well known as bugs. And we have no idea what level of quality assurance and testing. In fact, we have a suspicion that we are the testers and we are the quality assurance system, and we have no idea what they did internally in terms of rigorous testing and quality assurance. So that's a problem. More of the inherently unstable things. The problem is that it be data driven, and some of that data is rather constant. Hasn't been touched for a year or two, but it could also be the live internet that it's looking at. And even small changes in the data can have a large impact on the answers you get. And you just don't know. It's not telling you, if you'd asked us 5 minutes earlier, I would have given you a different answer or anything like that. And anything on the internet at any time, as we know, can be hacked by hackers and certainly fed lots of fake news. Maybe half of everything there is already that. So inherently unstable. By the way, I have a lot of fun with these systems. Very interesting, but trust but verify, the Reagan slogan is probably what we need to do. So conclusion is, you don't know how it's designed, and they're not going to tell you. And so even if we got all the code and all the data, quantities so large that we probably couldn't consume it. For example, Musk's original automatic driving systems on the Tesla were 300,000 or 400,000 lines of code, just to indicate how big code can be of this nature. And we all know the internet's terribly large. Okay, so looking at the details wouldn't tell us whether the system is truthful, accurate, false, fake, or useful. We couldn't derive it from this information. So we're left with the old ploy, which I'm going to highly recommend here, of focusing our attention outside the black box of the AI system and saying it doesn't matter what's inside the algorithms and the data. What matters is what it does. And this, at least, we can observe, we can test, we can measure, and that's still far from perfect, but I think it's a more promising approach than trying to get somebody to read the code and tell us what it does. Okay, so I'm going to suggest that we need to understand the critical properties of the AI system, and those properties, those qualities, need to be quantified, measurable, and there are things like transparency, explainability, and provability. Here we see a non-numeric version of it from PwC consultants with the blah, blah, blah nice sounding words that actually tell us nothing specific and have several ambiguous words in their formulation. So that's just not helpful. Okay, so we have a state we can call the mystical complexity of the AI system, the unintelligible complexity inside the black box, being fed by live internet information, perhaps, and everything interacting with everything in ways that even the creators of the system openly admit they haven't got a clue as to what's going on. Okay. So here's just some fun little AI constructed drawings of the chaos inside the black box. Some of you will know this chap, Geoffrey Hinton, sometimes billed as godfather of artificial intelligence. And he makes this point: these systems, the large language modeling systems, are very different from our intelligence. In other words, using the term artificial intelligence may be misleading and false. We'll get back to that later. Okay. So, point number one. The first thing we need to do to begin to get control of everything is to decide which qualities we're interested in. And I promise you, there's not just one quality like the reliability. Many IT people, when they say, quality, only mean bug freeness and nothing else. But we're using quality in the, all the ilities just for starters. And I promise you there are at least 10 qualities that are generic and always interesting. And if you ask an AI system to generate 50 different qualities of an AI system in a prompt, it will. And they will be pretty good and pretty relevant. I shudder to think if you asked it to generate 5,000, but it would probably go for that too. Okay, and we're going to use the set of qualities we suggest. Now, this is the set of qualities that we are interested in for our purposes. It's not somebody else's idea. And this will be very tailored to our stakeholders and what they care about. But we can get lots of good advice from AI systems to what these qualities might be if we are in doubt. Okay, we also need a set of AI systems costs, which are not just capital costs, but they're operational costs and maintenance costs and costs of porting data from one to the other and all that kinds of things, and time, people, money. So we need sets of costs to understand the economics of AI. Okay, here's a little model which we call the Penta model, where here are the resources or costs. Here are the values or qualities. Values over resources is equal to efficiency. The technical designs are what give us the values and the costs, and thus the efficiency. And the scope is functionality, what it does. I mean, does it generate poetry, or does it generate videos, or what does it do? Okay, there's a little paper on the Penta model which has some fun. Now there is an effort, and there are some people at BCS. Adam Smith is one name that comes to mind, that are working with IEEE standardization committees to pin down the ethics of AI. And they've decided they need to tackle these things like, transparency and things like that. And here's their very, very basic model for ethics. What is the human benefit? How responsible is the system? How transparent are its decisions? And what happens with education and awareness if you do it? There was, in 2016, when I first got involved with this, there was a paper presented to Barack Obama at the White House by about 10 famous United States universities and IBM in Japan. And they primary message was, here is a set of 8 primary characteristics of AI: transparency, our old friend again, security mentioned earlier, safety, that was Musk's favorite thing, and etc. And they called these, strangely enough, principles, because I think that's wrong use of terminology no matter what. I would call them qualities. Or and then they immediately proceeded as good academics with no knowledge of quantification of anything into the poetic description or definition of transparency with a set of about 10 ambiguous words. I think they should be ashamed of themselves for not defining things as important as this more clearly, but they have since, both at IEEE level and IBM Japan, and IEEE has specifically said, Tom, you're right. The nice sounding words are not good enough, and we definitely have to go the route of quantification. Okay, so it's really a strange culture, especially coming from the so-called best universities, to use, improving by how much, probability, what kind of, guaranteeing how well. On and on and on. I don't know. I can't believe that grown people do this in public legally. Here's another chap who caught my attention, Tim O'Reilly. And long story short, save a bit of time, he says, of course, if we want to understand these systems, we have to use metrics. By the way, in 1976, I published a book called Software Metrics. And still working on it, not giving up just because the whole world doesn't do it yet. Had a lot of help from BCS in getting the message out in the courses we held in London and Scotland and other places. Thank you, Margaret Ross and Quality Group, for sponsoring that through so many years. Okay, so here's again the IEEE recommending, long story short, that we define transparency well, and I hope our BCS friend Adam Smith is on to the task. Now here, I have got an example for you. If you wonder how in the world do you define transparency quantitatively, I'm using my planning language, okay? Here's a free copy of a book for understanding how to do that called Quantification. And here's the tag, the name of it, transparency. Here is what I sometimes impolitely call the bullshit level. In other words, a nice series of words that you might get from a politician or top executive. Here is a scale of measure. Here is where the rubber hits the road and we get serious. So the scale of measure is saying, okay, we're talking about speed here. By that, I mean light years. Got it? So when I say 300, I mean 300 light years is my speed. So that's the first stage of any kind of quantification, is defining a scale of measure. Then we need some ideas of, here's an example of what we call the narrow priority objective. That's down here. And here's some detail about it. We don't have time to go into detail about it, but basically I have a status level of 24 transparency according to this scale of measure. And I want to leap forward to the magical Douglas Adams number 42, getting twice as good by 24th of May, 2022. That's my deadline. And here are a bunch of parameters which basically say who, where, when, what, why we are going to make this leap. So again, if you want to understand this, that's what we've been holding free training courses at BCS on since goodness knows when, but about 10 years ago we started. And it's the details are published in the free books, this one here. Here's a little bit more detail on the scale. And again, I'm not going to go into the detail to show you how detailed it is. The scale of measure has a bunch of parameters. like decision criteria, transparency level, stakeholder type. And then we've defined the decision criteria. Here's that set, oops. And we've defined the stakeholder types down here, and we can then use them as parameters to define for any combination of these ideas. These are our specific local ideas that we want to use our AI system for. Okay, so this is language at its best, its most advanced, a very advanced way of quantifying and clarifying rather complex systems, but in a way which is actually so simple that even a top manager can bear with you while you read this during a management meeting. Here is just an enlargement of that scale of measure. It has to be read slowly and you have to think what's going on here, but the point is we can do that if we want to. So here's a little hierarchy of ways of looking at things. And, we start off at sort of a bird's eye view at the very top, the set of qualities that define what we're interested in. And then we get down to the level of there's one quality called transparency, and we say, and we have a certain scale of measure with certain parameters to do it. And finally down to some numbers like 42 units forward. So there's a sort of a hierarchy of information for each of the qualities. These represent, here's the quality transparency emanating from the AI system, and here's 28, and we're going to leap forward to 42 when we have achieved the level of transparency we want in our system. The ethics committee of IEEE is working on human rights, and I've shown this to our friend Adam Smith and encouraged him to use these methods. He encouraged me to join the committee, but I opted out. Too much bureaucracy for me, and I'm hoping Adam will represent the side, the BCS there. But so here's human rights, just an example. We want to go from 1 in human rights to 42, and here's our wish level, the stakeholder desire, and we want to get to this level 42 by 30th of April 2029. Here's the bullshit level. We use that to say, okay, let's make that clearer, more structured, and more quantified. And this could come from the CEO, and you don't want to say it's a bullshit level. We just say, thanks for your ambition, giving us vision and direction, Mr. CEO. And then you define your scale of measure for human rights, and you define how bad it is right now for professional bodies, corporations, and startups. And you say you want to get 42 times better by a certain date for these types of things, and away you go. But long story short, simple example of defining human rights. Or how about prioritizing well-being? Again, the same structure here. This is your typical language structure in a tool called Valplan, built by a Brit called Richard Smith and used on our BCS courses for many years to insert this class of information in a coherent way. Okay, so this is the detail of the well-being scale with, for each parameter, more detail about exactly, this is really defining our scope or domain, okay? And finally, accountability. Notice same pattern, just different information, but strictly logical, clear definitions, not frozen, but can be improved and enhanced anytime we get good ideas for doing so. Let's see, I'm on slide 29, and I've used 24 minutes of the talk. That's good. Okay, there is hope, even though we did get a late start. Here is accountability, again, scale of measure, and other information we capture about accountability in planning. Okay, So the summary thus far is that all AI system qualities and other stakeholder values can be defined quantitatively, or if you like, as a metric. Refer back to my software metrics book, 1976, where, by the way, I defined agile on page 214, if anybody's interested in that. And so by doing so, we get a clearer, stable tool way of thinking for comparing AI system performance. Let's say you have 10 qualities and you have 10 different AI systems, and you can now put these on a table and look at the various degrees of quality. And I'm going to show you an example of doing exactly that, which I suggested for the Obama White House without the president actually knowing that I did it. So coming up. I'd like to introduce now the what I call the stakeholder, the idea of a stakeholder model. We are a little bit, IT people are a little bit narrowly, maybe for good historical reasons, focused on the customer, the paying customer, very important, obviously. And finally, they woke up.
Interrupt you for a moment, please, because we need to order if we're going to get it on time. So
right.
Need to count how many people we've got.
Okay.
Could you put your hand up if you'd like some food after this talk? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that's 17 people. Is there anybody with special dietary requirements or doesn't like pizza?
I'm vegan.
Vegan is fine, yeah.
Vegetarian.
Vegan?
Vegetarian. Vegetarian.
Yeah,
Vegan's
okay.
fine.
So we'll get some plant-based stuff. Thanks very much. Sorry,
Okay.
Tom, continue.
Very important. I'm looking forward to my own dinner. So, okay, so new but related topic, a new way of understanding AI systems is through the eyes of the beholder, known as the stakeholder. The strong tradition of respecting the wishes of the customer is valid, and the strong tradition of user stories, use cases, and things like that, very valid. Okay, but the fact is, if you ask who are all the stakeholders, you'll find at least 10, if not 30, stakeholders like European law or maybe British law, which are not customers and they're not users, but they absolutely have to be respected with an AI system that's stealing all your personal information. Okay, so many stakeholders are not biological. They're things like laws, contracts, agreements, customs, traditions, and culture. Okay, so basically, now if you want the detail on this, very happy to offer you a free copy of my fairly new book, Stakeholder Engineering, which goes into greater depth than any other known textbook on this subject. Proved me wrong. And but basically it says we've got to shift culture a little bit here. People talk about stakeholders these days, but they don't do much with it. They're still back to the users and customers and hardly anything else, completely forgetting things like laws and regulations until they get an 800 million pound fine from the European Commission, hello Google, and get threatened to not be able to market their stuff in the European Union, hello Apple, okay, because they didn't recognize powerful stakeholders for their systems. Apple example is for their AI system, by the way. Okay, I call these tools for understanding the AI system technoscopes, and there's a free copy of my book called Technoscopes, which is my way of looking at complex systems like AI systems so that we can understand them better. So quantification of qualities is one technoscope, and analysis and specification of stakeholders is another technoscope. Stakeholders are the direct sources of requirements for the system we're going to build or evaluate. Okay, and so they're fairly important. Here on the right-hand side is actually a little stakeholder model for, I believe it's for an AI system. And let's see. So, and each one of these stakeholders might have, on average, 3 different values, some of which may be the same value as another stakeholder, but at a different level of quality or different delivery deadline. Oh, this is getting very complex. Yes, it is. Therefore, you need a planning language that's capable of coping with it, and user stories and use cases ain't that planning language. Okay, so here we are again with that same model. And again, if you like, it's a way of perceiving what's inside the black box known as AI. If you like, you take one stakeholder at a time, and you take the values that that stakeholder has and say, can we ascertain anything? Maybe the answer is no, about this AI system with respect to the transparency from the point of view of a critic or a consumer advocate or something like that. So I think this would be repetitive now. You can scan that, but stakeholders are basically the source of all kinds of requirements that then can map onto for example, a selection process for selecting the right AI system for your project or organization or something like that. Okay. Now, here's something I did in an attempt to rework the model that for the Obama White House. I took all of their values, so-called principles, wrong terminology, and which I have quantified. The right-hand number is where we're going to. Okay, and then I took the different options, and each university had their own favorite AI system. No surprises there. And I built what is known as an impact estimation table, free booklet right down here at the bottom on value impact estimation tables. But and so what we're going to try and do is say something numeric about the degree to which this the UC Berkeley deep mind, or whatever they call it, helps us achieve the AI accountability, the AI controllability, the AI ethicality that we have decided we want in our organization. The particular UC Berkeley ones have a lot of question marks, meaning we have no such knowledge and AI Berkeley is not giving it to us. Oh, one exception down here. So very nice to know about the transparency, not very nice to know nothing about these things and have a salesman at your door saying you should buy the UC Berkeley system. Okay, so we did the national so-called national technique one. This is just made up as an example, and we got various degrees of compliance or contribution to our values. And by the way, we took one cost, operational cost, relation to our budget. From this, we can compute the sum of values over the sum of costs, and you get a value to cost ratio. And we automatically, in our little spreadsheet, which it really is, compute the ratio. And for the 3 things we did anything about, this the 9.10 ideal XAI technology is the winner. But we also have some really advanced things where we can look at the data we have with respect to the worst case and the credibility of the data. In other words, the risk. And pull out, maybe get different conclusions if we care about the possibility that the table is dead wrong. This is just what you can do in any spreadsheet, is take the table data and here's the sum of all values and the sum of costs for one AI system. Here's the sum of all those values and the sum of costs for another one, etc. Here you have a pretty bad one, very low sum of values and equally costly compared to the other ones. I don't know, I think this one, whatever it says in small print, is the one I want. That would be the XAI thing. This gives you a systematic method for deciding to choose at least which AI model to start with. Okay, let's see, I've used 35 minutes on slide 37. Feels very comfortable. I will coast in towards the end and relax a little bit. I held this same talk for Margaret and an academic group, so I had to comment on the academic viewpoint. And I believe that students, and especially research students, not to mention their professors, should consider using these tools for researching AI developments. And they largely don't even know about these methods. That's called ignorance in the face of published information. And I'm really shocked at what I see there. Don't get me started, okay? But anyway, there's a nice little free book, Competitive Engineering. Had an interesting adventure. There's a fellow called Nicholas Coutts who is working at Imperial College and also University of Barcelona. He has done over 220 startups over the last 10, 20, 30 years. He uses language and the competitive engineering book. I've worked with him on several real startup projects. And he says after 3 years, his startups, 220, have 83% success rate using all of the competitive engineering or language methods for clear thinking. The European average, not using my methods and his support, has 49%. The American Silicon Valley survival of startups is around 1 in 20, you may know. What they do is they kill everything off after about 6 months. One of the interesting things that Nicholas told us is that they insist on using a 3-year time horizon before they decide to kill off a startup as being worthless or not, whereas the Yanks are very impatient to find their gazelles and earn a lot of money, so they kill off things after about 6 months. Nicholas also told us that he had no use whatsoever for any university education to help the startup people do the startups. They were better off learning by doing things like these quantification of qualities and impact estimation tables. I have a letter to that effect, which I've published if anybody's interested. Margaret decided that we're going to get Nicholas to hold some talks for BCS about this incredible British and European accomplishment. Forget American methods and American financing. Europe does it better, we're proud to say. Okay. You might think I did a hard sell on my methods here, but you know what? I don't want your money. I don't want your business, but I would love to get your mind going in the right direction. Or please tell me if you've got a better direction. I might have something to learn. Okay. Let's see. 39 minutes, slide 39. There's hope. So this is all in aid of saying what we alluded to earlier, the LLMs, i.e. ChatGPT, etc., that we're looking at, they really are not intelligent. And they certainly, I think everybody agrees on that, they are not the artificial general intelligence, which is acknowledged to be the ideal. They are just if you like, a very advanced Google system. You may have noticed that. And we're working on it. But there is many people don't like the term intelligence. They feel it's just a marketing ploy. But anyway, if it makes my Tesla stock go up tomorrow violently, I'm not gonna badger people about that. I'll just cash in on the stock before people wise up to the fact that this is not an intelligent system. Okay, so moving right along. Here's a man I'm working with who is building a, let's put it this way, part way to artificial general intelligence system at graphmetrics.com. My son is a co-founder of the company, and I'm an investor. And it's used for the moment by building industry to swallow everything you would know about a building and build digital twins, and do so quite automatically. So it's a bit specialized. It's not totally general artificial intelligence, but what it does is pretty mind-blowing. And this fellow is an architect who's built the system in Lisp for the last 3 years, and it's working and performing, we're glad to say. And he has some opinions, which I therefore respect. And when he says there's no intelligence at all in large language models, I believe him. Okay, here he repeats it in an email. Okay, so argue with him if you don't like that opinion. How do we measure to see if the artificial intelligence is like a human? Well, the Turing test. Some people say it's passed it, others say no, it didn't. But okay, there's some well-known approaches that people long ago figured out that that these systems should pass if it were really human intelligence. So slide 43 for 42 minutes, good. I've introduced to you very briefly the Penta model, which I think is a nice simplification of everything I'm talking about it. I invented it together with Al Shalloway. Some of you will know we were looking something better than the famous or infamous iron triangle, which we think is highly misleading, to put it mildly. But in this case, it serves the purpose of emphasizing some of the main points. That, for example, understanding values and resources is a great way of understanding the efficiency of an AI model. Designs is the way you get the values and resources, but it's difficult to analyze them for various reasons. And here are some simple examples of the ideas. But again, simplified model of my language, the Penta model. And almost finally, the principles of understanding. So number one, we cannot hope, to translate AI apps' detailed complexity. In other words, knowing the computer programming, knowing the training data, plus the prompt, plus my book I just read into Gemini Pro 1.5. And we can't translate that into understanding the qualities and costs. We've got to go outside the black box. This is a description of inside the black box, and look at its behavior that we can observe and test. Okay, we have to understand AI through multiple quantified qualities and costs, plural qualities, plural costs. Missing one critical quality will get you the wrong answer. Missing one critical cost will get you the wrong answer. You've got to have a complete enough set to model your environment, your needs, right? And we can, using these tools, we can take any stream of AI systems and model them as per the illustration I showed you, the table and the method in this free booklet. Identifying critical AI stakeholders will help us broaden our understanding of the requirements or values and costs and other constraints, by the way, that we need to understand in order to understand something significant for our purposes about various emerging and changing AI systems, okay? If you can't get the data for the transparency and security and safety about an AI system's qualities and costs, then with the 4 question marks on the table, you have what is popularly known as known unknown, also known as risks, which you can do something about, but it might cost you research, measurement, testing to get some better knowledge. And but the option is to dive in with unknowns and hope for the best. And so, last slide, and various ways of contacting me and doing stuff. And you will discover that I have a set of about 60 slides afterwards, which are just going into the Obama White House quantification detail, another talk I heard held earlier. So it's in the set of slides here, and there's a separate thing here, but I don't see any reason to use that at this point. So now that I've used 46.5 minutes, I hereby declare lecture done, ready for questions. I think I will turn off my slides in the hope I won't have to get back to them, and look at your lovely faces, and I will turn the chat on. And I'll leave it to Immo to be the host, unless Margaret wants that rolled out. I don't know.
Thank you, Tom. You mentioned Quantia. Could you tell us a little bit more about that tool and what we would have to do to gain access to it?
Sorry, which tool was it?
I think it was called.
Yeah, I said Quantier. Right. Let me clarify. Now, Quantier is the name of a booklet.
Okay.
So if you use that link, and that a booklet is a tool. So it's absolute, but it's a tool in the form of instructions of how to quantify any AI value or quality. See, most people start up by saying, "Oh, that's too difficult to quantify," and they've got all kinds of excuses. By the way, if you are so weakly taught at your university that you cannot quantify any quality, and at the same time we have a bunch of free ChatGPT AI systems that will quantify any quality with a scale of measure and no hesitation and no cost, you, buddy, are out of a job. Who would want you, who hesitate and can't do it at great expense, when an AI system will do it instantaneously and as good as any human being does it? Okay? So, yes, there's a real threat that people who cannot do this will be replaced by AI systems. Now, by the way, what's the hope of survival? I've discovered it. I don't feel threatened at all. It turns out the interesting thing that we can learn to do is to ask the right questions. Like, who are the stakeholders for us? What are their values? Suggest how to quantify the values. What levels of performance should be going? In other words, we need to be smart enough to drive the AI system to serve us, not replace us. Now, by the way, there was another tool mentioned called ValPlan. And there's that is an app built by Richard Smith in England, and it supports all of the competitive engineering. It's built on the competitive engineering book text, right? So if you want an automatic tool which understands language, use ValPlan, okay? anybody's welcome to build their own version of it if they want, but we don't have any competing versions at the moment. By the way, Jim Slavin has an interesting thing in the chat. Provide the top 5,000 qualities of ChatGPT. And it said, well, tell you what, that's pretty extensive. We'll start with 100 qualities. Oh, here's the first 250 qualities as a starting point. It's amazingly agile in giving us what we say we want.
Anybody who's online and wants to ask a question, please just unmute yourself. So how would one actually be able to start using ValPlan? Because doing this stuff manually is
yes, yeah, right. Now, I'll give you some options here. Number one, for 10 years, about 10 times a year, Margaret, we held BCS courses at BCS, and from about 2016, we used ValPlan. So there are a large number of BCS members who have learned to use it. Now, how do we learn to use it? The same way Nicholas Coutts does it. We give people a problem, and we give them access to the app, and the little bit of coaching and teaching, they pick it up and do it. By the way, Sohir has been witness to this for 10 years, and I'm not exaggerating. No big training course on how to use the app. They just picked it up and did it. So in other words, how do you learn to do it? But by the way, there's an enormous quantity of training hints and prompts built into ValPlan. Not to mention, it's built on the free competitive engineering book. You can read the book, okay? I don't any longer hold these training courses. I'm retired, but if there are other people, I can name some of them. Example, John Coleman, who are currently teaching my methods and will be able to teach with regard to ValPlan, okay? So I would say ValPlan is like other simple apps where we don't go to do a training course on Word or PowerPoint. We just start using it. Okay? Now, that's one piece of news. It's it's designed to be no big trick to learn to do it. Now, here's the other piece of good news. I find that using, for example, ChatGPT, which happens to know about language. I don't know how it knows about it. It won't tell me where it got it, but I can just tell it I want things done in language, and it will, and it does it very well. It does it as well as any of my BCS students. And I simply, I can supply people with examples of what I've done, okay, the prompts. But the prompts go something like this. What is it Jim said, William said, he works in IT disputes with contracts. Okay, for the area called IT disputes with contracts, give me the top 10 stakeholders with their top 10 values. That's the prompt. It will do it, and I promise you it will do it well, okay? You can even say, explain to me how you arrived at each of the 3 values for each of the 10 stakeholders. And it will do it, and it will give you better reasoning than most humans will do it. You can then give a prompt saying, I want you in language, and sometimes I put in parentheses, scale, wish, things like that, in case it's in any doubt whatsoever. I want you to define the top 10 stakeholder values from that set of approximately 30 values you had for the stakeholders, right, with 3 each, okay? And I want you to define them, and it will do so, and it will do so very well. And you can say, how did you arrive at the fact that these 10 out of the 30 you suggested are the most critical? And it will tell you how it did it, and it will have better reasons than most humans. You can then say, please give me 30 suggestions for architecture or design or solutions or means for reaching the 10 levels of performance for the 10 different values and qualities. And it will do so. And then you're kind of curious how good these things are. So you can then read in another prompt where it says, please build an impact estimation table with the strategies across the top, as per the example I showed you in the slides here, with the values and some costs on the left-hand side, and please rate them the best you can. Sometimes it defaults to high, low, medium, and explains that we haven't got enough detail to do any better, which is true. Sometimes I force it to give answers on a scale of 0 to 10, and to even explain what I called the evidence for why it arrived at the figure 6. And it does so. Okay? Again, so here we'll bear witness to the fact that this whole thing can be done in an hour, which is a heck of a lot faster than we ever did on a 2-day BCS course. Okay? And it's a lot cheaper. Okay? So I view the AI systems as a talented accelerator with extremely good skills and to help us get projects started. And then whether you bring these things into Val Plan, unfortunately, we have no immediately machine transportation way of doing it, so it would be manual. But so we could put it in Val Plan and use Val Plan to tune and agree on the plans and things like that. Okay, or we could decide not to go to Val Plan and just sort of get the plans approved roughly by the top management and then start. Oh yeah, I forgot. You can then say, take the strategy with the highest effectiveness in relation to cost and decompose it into 10 sub-strategies that can each be independently implemented and will give value. This is agile. This is sprints. This is agile engineering. And it will do so, and it will do so very well and very credibly. And now you know, and I ask you to score these things. It literally tells you what you should do next week and every week to get the value flowing, the value stream flowing towards the set of 10 goals that you have. Okay, so it literally gives you agile engineering within an hour. I've got examples of this I will send to anybody. I have published this I regularly publish such things in my X and LinkedIn accounts, okay? And I've published them. And but if somebody says, I can't find it, Tom, just send me one where you've done this. The most recent one, we were having a knockdown, drag-out battle. Margaret was there in the 25th annual Gilb Fest, whatever that is, secret society. And we were getting into religious discussions about which religion or way of thinking was best for humanity. So after we were done about 6 in the evening and before we started 9 the next morning, this is last Thursday, I've got a thing called, the keyword is Bible. And what I did was I asked it to generate 10 different ways of thinking, 5 religious texts like the Bible and the Veda texts, and 10 philosophical texts like Stoicness, and use and rate that against the values of different stakeholders for these things, which are not just the individual looking for a way to run their life, but they're things like historians, like my friend Lawrence Day, who was with us, who's written 3 books researching the history of real events tie into the Old Testament. Okay. And I got it to build an impact estimation table and rate everything, and came back the next morning and I held a presentation, which I'll give you a copy of, or you can use the keyword Bible or look it up on LinkedIn. I should probably be a nice guy and put it in the chat right away because it's not too difficult. I'm not scared to do it since my slides aren't there anymore. B-I-B-L-E. Oh, B-I-B-L-E. B-I-B-L-E. There we go. Bible analysis paper. Okay, there we go. This will be a nice little thing. Oh, that's good enough. So put it in the Zoom chat to BCS London. There it is. BCS London is not in this meeting. Sorry.
Into the meeting group chat.
Meeting group chat. Right. There we go. So there is the link to the Bible analysis that I completed last Thursday morning by working on it for about an hour on Wednesday evening. And it will blow your mind how quickly it was done and how well it was done. I had a bit of fun from a values to cost point of view. The Bible didn't get to the top 5 at all. But then to try and help save face for my Bible tutoring friends, I said, don't count the cost of learning the Bible and things like that, just the value of having done it. And then the Bible got into the top 5 ways of running your life. And Christians will be glad to know that they've got something that might be worth learning, even if it's a bit difficult to learn. In that particular case, I also used Google Gemini Pro, and I fed my competitive engineering PCF text, which you have a free copy of, in. So it was very knowledgeable. In other words, it was trained, if you like, in addition to everything else, on my competitive engineering text. You can all pull the same trick with Google Gemini Pro 1.5. But even without feeding in my text, all of the AI systems have picked up enough information about my language method from other sources on the internet, which they are not revealing to me, but they're very welcome to it. That was the short answer. But I'm very happy to give that answer. Look at that Bible thing. That is fun. Or your next religious discussion, or maybe your next political discussion. What about taking the UK political parties as a solution to all the world's ills, and then the values of a voter in UK, and deciding which party to vote for? I challenge somebody to do that this evening in 1 hour and show me what they've done. Any volunteers?
The problem is that what you know about the political parties is almost all fake, isn't it?
Right.
Not telling you the truth.
Right. But maybe the Chat GPT knows more about them than you do. But you can literally build an impact estimation table of political parties against your values, and then the cost to the economy, like how much in international debt is UK going to go with the Tories and that kind of thing, you know? And then you might get a rational decision of whom to vote for. And if your party scores very highly, you might send this off to the party so they can teach it to all potential voters to get their vote. The AI system says, vote green.
Speaking of green,
Yes.
slightly off topic, but have you looked into the environmental impact of actually running AI systems at scale?
Yes, of course. Horrendous. I'll tell you what, right now, I'm not feeling too guilty. And I'll make a bet with you that the costs will be driven down by those who want to drive the costs down. They just happen to be at the bad level of training which people are using right now. So I'll make a bet. The costs will be driven down, but that may be several years. You know, they may be driven down by a factor of 10 in 10 years. So I'm not too worried. It's not like these are doomed to be the case forever. For example, the Tesla example, when they went over to data-driven driving algorithms from algorithm-driven algorithms, was very dramatic. I mean, they went down from their 300 lines of code to, was it 30,000 or 3,000 lines of code instantaneously, and got better results. And that's moving in the direction of artificial general intelligence. So I'm not worried, because this is this stupid LLM modeling, and we know there are smarter things, and they've been proven that they do cost less. I mean, you can run the whole, look at what Apple's doing. They're going to run the whole thing largely in your iPhone. That doesn't worry me.
Thank you.
Right now, I read it in my car. That doesn't worry me. I'm not worried, but I am respectful. And should it persist and get worse, we all have to worry about it. But there's a simple mechanism called charging for the service, which will get people who really don't need it to not abuse it and destroy the planet. Right now, it's free, which is a problem.
Can I just raise one point? That's brilliant, Tom. Thank you. Coming from the Zoom side. But, you know, with Planage, you know, you're saying how you can use it for anything. I wondered if you could give the example I particularly like, which is four letters starting with L.
Ah, love. Yeah, right. Okay. I'll tell you what I'm going to do. I'm going to get the reference out, which is my TEDx talk she's referring to, and it's quantification of love. Okay. So there we go. So got it. Which has had 15,500 views as of last year. That's nice to know. And meeting group chat. Okay, so there's the link. It's if you want to spend another 15 minutes with me and learn how to quantify love, as in the Bible in Corinthians, quantitatively as in language, that's the talk that will explain it that Margaret is referring to. Okay, so what we found is language was designed not to help programmers program, like so much of the IT methods really have been designed to. It was designed to be systems engineering, meaning absolutely anything. And because it's absolutely anything, it can be used for absolutely anything, including religious planning, political party planning, Green Party planning, and love planning. Not to mention my life design book, where it's been used by BCS course attendees to plan their professional career. You want the book called Life Design. I think, being a nice guy, I'm going to give a free copy of the Life Design book, so you can all design your life. It's worth $1 billion, and we only charge $1 million normally. But I'm going to give you a free copy for the fun of it. Life Design booklet. There it goes. Free PDF copy. And into Zoom. There we go. So there's the free copy. Now, pointing out that we actually charge 14 euros for my rich friends who want to donate to charity. But since it will make you as rich as Elon Musk, it's obviously worth a few billion quid, right? And if you think I'm joking, ask me for the Musk Methods book. Okay, you want a free copy of Musk Methods? Or you just pissed off at Musk and you don't want to know how he gets so rich? I've been tracking him, and so I will, feeling very generous today, give you the Musk's Methods book for free. And if you don't have time to read anything else, there is one page where he states his 5 principles. And the first principle says that you need clear, quantified requirements, and you should be very skeptical of the requirements handed to you by the boss, the CEO, and the customer, because they're probably wrong. You should trust nobody, no matter how intelligent they are, and he's referring to himself if he gives you the requirements. And you should assume all requirements at all times are partially wrong and work your way towards more and more refined requirements. And then he, as an added thing in point 1 of 5, he says, oh, by the way, same thing applies to any design requirement. Just think about that. That's what he does. And that's why his stock went up by 6.5% today, which is pretty good for a single day.
Does I have a question?
Please, go ahead.
I'm Tolly. I run a wellbeing and inclusion consultancy. And one of the things in consulting that we're looking at is like incorporating AI to make things faster. But unfortunately, the issue we have is some of the issues you mentioned at the beginning, the fact that it hallucinates, we can't trust it, it's really bad at higher order thinking. And obviously, I think what made me think about my question is the fact that you've just said that we shouldn't trust people. And I think we can't trust people, we can trust something that we have no idea of really what's actually going on. And I think, sorry to go on and on, but I think with AI, there is this idea that it's just like the next best thing. But from what we've seen and from the companies I've worked at and with, it's really like not, it's cool in the beginning and then after a while there's issues. How can quantifying the quality in the way that you've described assist with these issues?
Okay. I think I know what your question is. By the way, when I teach my BCS courses and somebody has not learned at university to state their question in short, I say to them, please think until you can state your question in 10 words or less. That shuts them up for a while, and then they state their question. Let me guess, your question is something like this. Please do deny it. We cannot trust people, and we cannot trust AI to give us perfectly correct information about requirements or designs. So what can we do? Did I violate my own 10-minute, 10-word thing? Now, if it's a question something like that, I'll tell you the answer. The answer is you have to do what is highly recommended in real agile, and that is to deliver a little bit and get feedback. The feedback is a little bit closer to the truth than anything suggested by your boss and anything suggested by the AI system. Okay, and so we're back to Reagan's thing about with the Russians: trust but verify. In other words, I trust Musk to tell me a pretty good thing, but he told me not to trust him completely. So we're going to take our mobbing crew of 10 people. This is in the Musk Methods book from Joe Justice. And we're going to, in one day, try to achieve Musk's goal. And that's what they do. They have a numeric goal. They spend 10 hours and they try to actually achieve it on a real car coming off the production line. Beat that, Detroit, but they really do it. And then let's just say that Musk said, get to 42. And they try and they think they're going to get to 42. And at the end of the day, the cars start coming off the production line and the answer is 35. So they're short. They wanted to get to 42. The feedback tells them that Musk's idea of what to do didn't fit with the best designs or architectures that Musk suggested or they suggested. So they have to sit down and say, have we got any smarter ideas? So long story short, the only truth is the same truth in science. You have a hypothesis, you do an experiment, also known as a sprint or value delivery step in EVO, and you get feedback, which may be imperfect, but it's the best you can get. And based on that feedback, you change something to try to get better. And you keep on doing this until you give up or reach your goal. And that's the answer. Now, let me summarize that in 10 words or less. Don't trust plans, trust feedback.